We will do maths for VCE-Make-Math-Easy. First we'll start with derivatives. So the derivatives. First, what they are. Derivatives are like if we have a function like this one, x squared, and if you have a point here on the x line and you put a tangent through it, and this equation is called of the line equation is this, then this m here is your derivative of this for this function. The other way of saying it is that it's f prime of x, that's a derivative, equals limits when h goes to infinity. So h is a small advancement of the x-axis, so that's f of x plus h minus f of x divided by h. That's your other definition. That's definition of f prime of x, your first derivative. Yep, you should have known that from your theory in years 11 and 12 about derivatives. That's short what they are. So what first we're going to do, we're going to define what we rules, and we're going to define formulas. So our formulas that we will use. So whatever when we do examples and we do questions, then we need to use the formulas and the rules to get solution to the problem. So our formulas are our tools. Formulas are our tools, and apart from formulas we have the rules, and that's how to use the tools, and then we can build a house. Therefore, meaning we can solve our questions and examples. So first formula, so let's start with what our tools are. Let's see them. If we have f of x, f prime of x is, so these are the formulas. If you have a constant a, then it's f prime is 0. Tangents, right? So imagine tangents, the line being parallel with the x. Yeah. That one there. That one there to be parallel with the x-axis. So tangents is 0. It's a constant. You know what you mean. You shift the line up. That's horizontal. Form that number c. Okay. So if you have x on the power n, then your first derivative is n times x on the power n minus 1. Yeah. So that's it. So what else you got? You got some basic functions like all that we learned before, e and a on the power ax, and it's simple, just a, and you copy it, e on the power ax. Not much use there, just got a in front. So what's the opposite of e on the power of ax? It's logarithm for the base of e of, this time we use absolute value of ax, and it's 1 over x. Yeah, looks good. Now some trigonometry. You got sine of x, and it's simple. So let's do it generic. Instead of x, we'll put ax. So we'll have sine of ax equals a times cosine of ax. So now we've got cosine of ax is minus a times sine of ax. It's easy to remember sine is the first function that you learned. The sine, then cosine is the second. So derivative of sine is the cosine, and derivative of cosine is the sine. Just that minus in front. So first one is with the plus. Plus is always first. You learn the addition first. Yeah. Okay, that's the way to remember it. And we have tangents of ax, and that is a times secant to the power of 2 of ax. Yeah. And now we have the inverse functions of the trigonometric functions. So say sine on the power minus 1 of x divided by a. That's a generic form, that's why we put it there. And it's very simple. 1 over square root of a square minus x square. The same will be with a small change with cosine power minus 1 arc cosine. Then so we got minus 1 divided by the same, a square minus x square. So that's that. Tangents. So yep, left the tangents. This again, f of x and f prime of x, and we have the function tangents on the power minus 1 of x divided by a, and it's a bit different. It's a divided by a on the power of 2 plus x on the power of 2. So that's so far for our formulas. Apart from formulas, we have some rules. Yeah. So let's do the rules. Rules. Let's make them in a different color. The rules. And we had formulas. Formulas and rules. Formulas and rules. Now rules. The very first rule would be called the product rule. So we'll get its name here, product rule. Product rule. And the product rule says if a function like f of x is a product of two functions, or g of x and h of x, then its first derivative is the same as first derivative of the first one times the second one plus first one times the derivative of the second one. So the derivative of the second one. So h and prime t. So it's just derivatives change places, their product. First derivative the first, then derivative on the second, and you multiply them like this. They are, and then sum them up. That's simple. So the quotient rule and we divide the functions, right? So f of x is g of x divided by h of x. So when we have that, we just do it above, just divide by the second one, and the sign in between them is minus. So f of prime of x equals, now we have again g prime of x times h of x minus g of x times h prime of x, and then it's all divided by h of x on the power of 2. That's your quotient rule. There's one more rule, very important rule. It's called the chain rule. So we'll better put it there, up there. We'll remove this. And we'll put it there. And it's gonna be our chain rule. And our chain rule states that when we have a function f of x that's basically embedded, you have one function embedded in the other, like say h of g of x. So g of x is embedded instead of the independent variable. Then f prime of x is h prime of g of x. So treat the g of x as an independent variable x, or treat it as if it is, and then multiply that by g prime of x. Interesting, yeah. That's it. Another way of, very useful way, is you treat this g of x as, say, u. So you call, say, u is equal g of x, and then you can write your h of x. So yeah, you can h of u. You may say h of u. So that this everything, your f of x or your y, say, becomes h of u. H of u. So then differential first of y of x is then you differentiate y by u times du by dx. That's du here. It's not y. It's another way of writing it. It's sometimes useful. So that will be for our rules, apart from one more rule, and very useful rule that we'll put there in our last bit there, and I'll put it there, our last rule. And for example, if dy by dx can be written as 1 divided by dx by dy. Just swap them around. That's all the rules, no more. So much for the rules. So much for this slide.